Today's session is functions, and this talk is spread in three different sessions. We're going to talk about function basics, and then in the function basics, we're going to talk about scopes, function arguments, some some of the things that Python offers, extra functionality with functions, and then we're going to talk about advanced topics towards the third session. So let's get started. The first topic for today, a quick thing on what all we are going to cover. The first topic for today is going to be something called argument unpacking. Then we're going to look into defining functions and scopes, mainly, like how variables are in function. Right. So let's begin with the argument unpacking. This is something that will be used later on in the functions when we talk about some of the argument types. So what is argument unpacking? Suppose in Python, this is a fairly valid statement that you can say x comma y is equals to 5 comma 6. So this essentially assigns x to 5 and y to 6. It's also common that you can assign anything. Let's say you have a list, and let's say the name is Frodo and second name is Sam. And you can write x comma y to that. So as long as there's a one-to-one mapping available, Python will be able to assign this, right? Whatever is the value on the right to the variable on the left. So this thing that, for example, this list here is getting unpacked and assigned to the variables. Now, this is referred to as argument unpacking. Python understands what is supposed to be assigned to what. Now let's look at something more complicated. Suppose you have x comma y, and suppose the values here are, let's say, 1, 2, and 3. So when you try to do that, you get an error that too many values to unpack, expected 2. So looking at the left-hand side, Python somehow expected that, not somehow, but these are 2 values. So Python expected that whatever is here should be able to be unpacked into 2 values. However, this is not. There are 3 values here. So you got this error. Similarly, if you have the opposite, suppose you have xyz equals to 1 comma 2, or whatever the list that we had previously. Suppose you have x comma y comma z, and then the error is opposite, which is not enough values to unpack. So expected 3, but there are only 2 values available on the right-hand side. Right, so this is a problem. Basically, the left-hand side arguments are not matching the right-hand side arguments. So that's the problem here. And then there is a very good way to fix this problem if you need to. I mean, it's not always that you're going to be in this problem, but in many situations, this will help you as we move along. You can assign these value. For example, suppose there is an iterable like this, 1, 2, 3, 4, 5. And you do not know, let's say, you want to unpack into these 2, then essentially you can add an asterisk here. What this does is, positionally, the very first argument is assigned to the very first variable. So this is the first argument and is assigned to the first variable. And then rest everything else is assigned to y. So if you look at x and you look at y, then y contains everything else. And y is a list in that sense. Suppose you write x comma asterisk y equals to, let's say, Saturn, then once again, if you print x comma y, you will get s, which is assigned to x, and then a list of everything else into y. So y got all this. Python is smart enough to for you to play around with this. So basically, if you write, let's say, x, y, z, then there is a natural understanding that the first element should match to first, last should match to last, and everything else should be y. So if you write x, y, and z, right? So this asterisk helps us assign everything into the remaining number of variables. So this is the concept of argument unpacking. People can call it list unpacking or a tuple unpacking, whatever you want to call, but this is essentially you have an equal number of variables and you want to assign something, you can just do that. So suppose, let's say you're doing a loop, right? Suppose there's a list, L is equals to something like, let's say 1, 2, 3, 4, 5, 6, like that. And you're going to say, okay, for X in, you can just write, let's say, for head, comma, asterisk, tail in L, print head, comma, tail. If you do, oh, sorry, hang on 1 second, my mistake. I did a mistake here. So suppose you have L here. I will show you this example in a second. Suppose you have L, and let's say you're looping and you say each iteration head equals to this and tail equals to this. Then you always have the first element here and tail is the last element. All right, any questions in this?
Could you please just go over this last part? Sorry, I missed it a little bit of it. I'm sorry about that.
You mean this part?
Yes.
Yeah, nothing. So this is a list. You are assigning it to two different names. First name is getting the first value, and the rest, tail is getting everything else.
Okay.
I mean, there is nothing. This is just a simple argument unpacking. Once again, this is a list, and you are assigning you're dividing that into two variables. The first is pointing to the first, and tail is pointing to everything else. Yes. Yeah. Is there a question?
Yeah, Himanshu. So then I can just loop through the tail, right? Making another loop.
Yeah. Then you can just maybe look through another loop in the tail, and then whatever you want to do, you can continue.
Okay, thank you.
Yeah.
Himanshu, what if you do star head?
Your volume is really low. Whoever is speaking, can you please?
Is it better now? Hello? Is it better now?
Yeah, it's actually, yeah, it's audible. Tell me.
If you do star head, will it show the very first 5 elements?
Yes, that's right. So if you do, let's say, instead of this, let's say you do star head, then the head is the first 5 elements.
And so are those built-ins then, head and tail?
No, they're not built in. They're just some variable name. You can say star x comma y equals to L. These are just variable names. You call them whatever you want to call.
Okay.
So, but without always return a specific number of elements.
Can you repeat the question?
So in this case, for example, the head, so when you did star head, it's returned the first 5 elements.
Yes.
Or first 5 characters. So my question is, will they always, so what if you wanted to maybe return, say, only the first 3 characters?
Then you have to play around with this. in a way that, for example, if you know that this is 5 character long, then you can say x a comma b comma c like that. Then you have the x as the first 3 characters.
Okay.
So nothing to be confused about. This is basically, yeah, let's say you have any iterable. Suppose you have an iterable, let's say Saturn, and you say, let's say x comma asterisk y comma z. Then positionally, Python understands that the first value is to be assigned to the first guy. The second value is assigned to be assigned to the last value is to be assigned to the last guy. So these are positional matches. Then everything else goes to the asterisk. If you were to write x comma asterisk y equals to Saturn, then positionally only one thing is to be matched, which is this x. Rest everything goes to y.
Question.
Yeah,
Can you ever have more than one asterisk?
I knew you were going to ask this question. No, you cannot, because that's an ambiguity, right? So in this case, you don't know what's supposed to be assigned to what. So essentially you get an error to start expressions in the assignment. Okay,
Thank you.
take a minute, try this out. And if you have any question, you can ask me in the meantime.
Is it generally a best practice to include this if it's like a complicated function that other people might be doing?
Yes, that's right. That's why you have the documentation string, because how will people know what your function is supposed to do and what type of arguments it's supposed to handle? That's why you provide the documentation strings.
Can we also use the comments in the function?
Yeah, you can use comments in the function, no doubt. You can just write here something like if empty, then return none. So that's a comment in the function.
Okay. And when you run this, why is there a none in the output? So I did not understand that. If you run this, if you run this program right now, you see there's a none printed in the end.
This none is coming because somehow, okay, maybe what is happening here is, let's just see help of greet. Yeah, so now it's okay. But I think that's coming from the print function.
Oh, okay.
Yeah. So usually from the IDE, you will not get this. It's coming, that's fine. But I mean, from the IDE, you don't do these things. You don't print a help for anything. Usually you do it through terminals.
Got it. Okay.
Yeah. Yeah, try it out yourself. Take a few seconds. All right, let's move on. Let's call it, let's say, functions 2. I want to talk about an important thing, okay? This like some automatic polymorphism that comes with functions, that comes with Python in general. And You will notice that in functions as well. Suppose I define a function, okay? This function is very simple. It's basically going to multiply two things. Multiply, let's say, x comma y, and basically return x multiplied by y. Suppose this. We call this function, let's say, multiply and 2 comma 4. Just print it. So this will work, right? The arguments don't have any type to them, right? We don't say that what type is here. So it's really whatever you do, whatever you pass. For example, this is 2.3, suppose. Then this will continue to work. If it's a floating point multiplication, that will work. Or let's say you, even if it's not that, let's say if this is, let's say, hello or something like that, then this will also work, right? Because the string multiplication with a number is allowed. So this would not be possible in, let's say, C++ or Java, right? You have to write multiple function signatures to achieve this. So you get this. This is a strong functionality, although you have to be careful, because if you pass something that's incompatible, you may get into problems. So suppose this is hello and this is A, then you run this and you get an error toward when the last function call is made, basically that can't multiply a sequence by a non-int type string. But nonetheless, you have this power of polymorphism built in to the language. Now, suppose, let's take another function. Suppose I'm going to compute the intersection between two sequences. Suppose there's a sequence 1 and suppose there's a sequence 2. Right, suppose there are two lists. And you want to find the intersection between the two lists. You can do sets as we did in the last class, but I'm going to do it with order preserved. So let's say there's a list 1, 2, 3, 4, and then there's another list, let's say 2, 5, like that. So what I'm going to do is I'm going to compute a third list maybe, or some, what in that list, what I'm going to do is I'm start a for loop here, check for each item if that item is present here. If it's present, then add to that list. So for example, 1 is not present here, so nothing, no need to add, but 2 is present, so let's add 2. Then 3 is not present, 4 is not present, so this list will only contain the 2. That is the intersection of the 2 list. So let's just write this method real quick. Suppose I'm going to initialize the result as the empty string or the empty list. And then I'm just going to say for, okay, for x in sequence 1, okay, if x in sequence 2, if for all the x in sequence 1, if x is also present in sequence 2, then result.append that x. And in the end, just return result. And let's call this function. So intersect with, let's say, 2 list, which is, let's say, 1, 2, 3, 4, 5, 6, 7. And this is, let's say, 2, 4, 6, 8, 2, 4, 6, 9, or something like that. And you print it. So when you run this code, you're going to get what happened.
Results. I think you define it as RES.
My mistake. Yeah.
Yeah.
Result is not defined. Okay, let's go here. Let's run this code and you get the intersection, right? Once again, what I want to show you is that if, let's say, unintended things, if you, let's say, pass something like, say, Himanshu and maybe let's keep all small letters. If you run this, you will get an answer. So from the very first lecture, I've been talking about the concept of ordered collection, unordered collection, sequences, iterables. Now you will see that everything that's iterable, essentially, everything that's a sequence or iterable will be, this function will work on those things. And you can pretty much pass anything, any type of sequence here, and this will work. And they don't have to be even the same type. So this can be this, and the other thing can be, let's say, a list. You can say, let's say S or A, something like that. When you run this, this will also work. So you haven't defined any type here to these arguments, but they continue to work as long as your whatever you're passing is compatible. And all of these things like tuples, list, strings, they are all these sequences which are going to continue to work here. There is another topic that I want to talk about, which we will explore further in the last class as well. This is a slightly higher level topic. In Python, so this is not allowed in many languages, but in Python, you can create a function wherever you want to, essentially. Suppose that there is a variable x equals to, let's say, time equals to, let's say am. Okay, let's say I want to define a function called greet. For some weird reason, I'm going to, let's say, define it inside a if clause. I'm going to say if time equals to, let's say, am, then define greet, which returns, let's say, good morning. Else, define greet, which returns, say, good afternoon. Something like that. Right, and then you call the greet function here. All right, so let's run this function. Okay, print greet. So let's run this function and you'll get good morning. So you can define the functions in the if else clauses, just like this. And let's say if this was PM and if you run this again, then essentially you'll get good afternoon. So you can see there are two functions possibilities that can be created based on the if clause. Now, I'm not telling you to follow this example. This is a horrible example because you could have done this time check inside the function and just kept one function. But I'm just showing you the capability that we can create a function within an if else clause like this. This does not have too much of use until we combine this with another thing, which is defining and returning a function from a function. Okay, so I'm going to create a new module. Let's call this functions 4.py. Okay, suppose we have a function. Okay, and this function is called, let's say, func1. And it does something. Okay, let's say this, it's printing here. Okay, print in function1. Then inside this function, let's say you create another function, define function 2. And this prints, let's say, this is function 2. Now you can execute the function 2 from here as well. So now let's just write another print statement. Ending function 1, suppose. And let's call this function 1 now. So when we call this in function 1, then this is function 2 because we called this function 2 from within the function. Now, if we don't call it, let's just comment this out. Then notice the output. The function will not be executed. You can create a function within a function. And furthermore, you can return that function. Suppose in the end you want to return function 2. Okay, I'm not going to put parentheses because we are not calling it. We are just returning that function 2 back.
Just one
Okay.
quick question. The scope of that function will be only inside function 1, right? Or
At the
can we-
moment, yes. But as soon as we return it, then it will not be the case.
Okay.
Yeah. So when we run, let's say function 1, the function 1 is going to print this, then it's going to create another function. And in the end, this will return a new function, function 2. Suppose I capture the value here. And then I say, okay, let's execute X. Let's run this code. And now you see, first we print in function 1, end of function 1, and then we are printing X. But that is, we are reaching that function body and we are saying execute. Right, so let's just quickly look at how this flow worked. You had a function 1, which did certain things, and then it defined a function 2. And then it returned the function 2. So when you said X equals to function 1, when you said this, then the very first thing is that this function is going to be executed. When this function is executed, this function 2 is going to be created somewhere. Right? There is a name function 2 which is pointing to it. So this is the function which is doing something. Later on, you say, okay, return this function. Just like you would return a number or list or something. You say X equals to function 1. So this essentially return this body. So this X essentially is now pointing to this function body. If you do this, then you're saying whatever this X is pointing to, execute that. So this body gets executed. Now, why would we need that? It's beyond the scope of this course, but if you're familiar, maybe think about the factory patterns. That is, there is a function which takes in an argument, and based on that argument, it can generate some kind of a function and return that behavior. So in this function 1 is not returning some kind of a value. It's returning a behavior, right? Currently, it's hard coded that we're just returning function 2, but you can take an argument, maybe something, let's say some kind of argument, let's say time again. And then based on the situation, you can return the appropriate function back. But really the scope is beyond this course at the moment. But you can return function from a function. I use it a lot doing, for example, the lead code programming. Whenever you have a function and you want to write, let's say some kind of a recursion, I create another function here and I just call it from within the function. That's my use case, but it's not that much. I mean, it's not that helpful.
I have a question.
Yes, tell me.
Do you need a parentheses at the function 1? It doesn't run in my code without runs.
What do you mean by that?
X equals func1 without.
Are you referring to this line?
Yes, that. Why do you put the parentheses?
Yeah, I mean, because you have to execute it, right? If you
Yeah,
write X equals to func1, then you're saying point X to the same place where the func1 is
I
pointing.
cannot execute with the parentheses. I don't understand. I get an error.
When you try to execute it, you get an error?
Yeah, with the parentheses.
What is the error that you're getting?
Non-type object is not callable.
So this is pointing to some kind of a none.
Yeah, I don't know. Maybe I
We
could.
can look at your code after the class if you want.
Let me see.
What you can do is you can take your code, post it on Discord channel, and I can look at it
Okay.
as soon as this class is
Try
done.
to find why is it. Okay, thank you.
Any questions in this?
Are you going to talk about like higher order functions? You pass in a function as an argument?
Meaning passing functions as the argument within the function?
Yeah.
We can talk about it later on, yes. I mean, yeah, I was not planning this particular class, but certainly I was not going to talk about it, but I can talk. Yeah, no, no problem in that.
Oh, I found the difference. I didn't put the return function too. Maybe that's the problem. I forgot to put the return.
Shouldn't be a problem with that, but it's okay.
I'm trying because maybe I get a different result. Okay.
Okay. Yeah, I mean, so this, just keep that in mind. So if you're not returning anything here, then this will return a none, and then you're going to try to call a none function. That's going to be an error. You get some kind of error that. Hang on. What?
Yeah, that works now. That was
Yeah.
the problem. Thank you.
If you run it, then basically it'll say none type object is not callable. This is happening because you're not returning anything. You're returning a none. So this x is equals to a none. And when you're saying, okay, execute this none, that doesn't mean anything. All right, so now let's get into the discussion of scopes. Okay. In Python, we have dealt with scopes already in the classes so far. And how they work is this way. Suppose I am in my program or I am in my shell here, this shell, and I say, okay, let's say there's a variable called s equals to Saturn, and suppose I say len of s. Then this len worked automatically. Whereas if I tried to say, let's say pi, then pi would not work. I would have to say from math import pi, or I would have to say import pi, for example. Let's just take this example, import pi math, and then math.py. Then this will work. So what is the difference here? And how is this working? We'll have to understand the scopes a bit. When you run a program, when you start your shell or when you're writing code, there is something that is always available to you, and that is called built-in scope. That's available everywhere. Whatever code you're writing. Suppose in your code space, you have two modules. Okay, this is called module 1 and module 2. And suppose you define a variable, let's say name equals to Sam. Then this, when you define this, let's say in your module, then this becomes a module level variable, and this is available now in the rest of the module. So this built-in was available everywhere in all in every single module. But if you define something within the module, then that name is available inside the module. Right. So this is called built-in scope. Then this is called global scope. Now, if you define, let's say, a function, and if you define something here, let's say name equals to whatever, then this is only available within the function. It is not available outside the function. We'll see this in example very clearly. This is only going to be available inside the function. This is called as local scope. Okay, so there is a built-in scope, which is things that are available for anybody to access. Then there is module or global scope, that are things that are available within the module for you to access. And then finally, we have local scope, that is names which are within the functions and are only available within the function. Now let me show you the example to make this more clear. Suppose that here in the function, I write s equals to Sam, and I'm going to write print s. When you run this code, let me fix this. When you run this code, Sam will be printed, right? So this is pretty clear. We have already seen it several times. That For example, this print function is available, is a built-in function, which is available to us. This is a built-in scope. This is available everywhere. You don't need to import anything to get access to this function. Okay. Now suppose that there is a variable inside a function. Let's come here. And suppose you define a variable here. Let me find out. Let me create a new file. That's much more simpler than this. Okay. Let's call it scope1.py. Suppose I create a function def func1, and inside this function, I'm going to say x equals to 5. Okay, and suppose I come out here and I say print x. So let's run this code and you'll get an error that name x is not defined. What do you mean by that? Why is the name x not defined? Because the name x is a local variable inside the function. It is not defined outside this function. You don't have access to it. Right? Whereas, let's say if some variable was defined on the module level, let's say there is another variable called, let's say y, which is 10, and you write, okay, print y. So when you run this, notice the y is getting printed, no problem there. But x is a problem. Y is a global variable, right? This is defined on the module level and it's available everywhere. Whereas x is a local variable which is not available everywhere. So let's play around with this to fully understand the implications of this thing. Suppose I'm going to define a global variable on the module level. Let's say this is called 100. And suppose I'm going to define a function, define function 1. And this is going to say, let's just say print inside function 1. And we say, okay, print x. And we call the function 1. Now, if you run this code, this will work, right? This is defined at the module level. So anything that's in the module, you have access. This x is available there. Just like this print is available because it's a built-in function. This x is available here because this x is a module level variable, a global variable at the moment. Let's create another function. Let me just copy this first. This is called function 2. And let's say inside function 2. And suppose I'm going to say x equals to 200. Print x. Then I'm going to call function 2. When we run this, inside function 100, inside function 2, 200. When we did this, you might be wondering, what is happening with this x now? Have I reassigned this very value here? So let's print x. Let's say, let's print the x before calling the function, and then let's print it after calling the function. So you can run this. Yeah, sorry. Let me fix this. So you're inside function 100, then before calling function 2, it's 100. Then inside function 2, 200, and then after calling the function 2, it's 100 again. So this is an important concept to understand. The local variable is completely separate from this global variable. These two things are not connected. Okay, anything you do inside this function block is inside this function block, it lives and dies there. You define x equals to 100. An object 100 is created and x is pointing to it. Then you say def function and you write x equals to 200. Then another object is created, 200, and then there is an x pointing to it, but this x is this local variable here. These two x are not connected. They have no relation with each other. Whatever you want to do with this, you can continue to do with this. This will not affect the original value. If you have done any programming language, then this is similar to, any other programming language so far. Any questions?
Is there a way to call the x equals to 100 inside?
Yes, so I'm coming there now. So now if you want your x, the local variable, to actually reference the global variable, okay, if you want this local variable to reference it, then there is a keyword called global. You can explicitly say global x. And then you can write x equals to 300. And you can write, let's say, print x. And once again, let's repeat this. So before calling, let's say, function 3, the value of x was this. Then function 3 you call, and then you after that say function 3 after this. So let's just run this. Just give me a second. Let me just clean this up a bit. All right, let's run this. And now notice that before calling the function 2, this was 100, but inside this local variable was 200, and now it's 100 again. But after the 3, the variable has changed from 100 to 300 now, because we are explicitly saying that we want to refer to this global x. We are not creating a local copy. So you have to write just this kind of a keyword global, and then you have to refer to the global variable. Any questions so far? There is one final thing remaining. There is something called non-local scope. Okay, and I'll probably cover it in the last lecture, because I don't know if you guys will use it ever, or if you do not use it. I have never used it in real work, but it's like global. But if you have function within a function, then essentially, if you want to refer to a variable which is in the outer body, suppose x equals to 500, then you can refer to that by writing non-local x, just like you do global. But we'll cover this later on. Don't worry about it for now. We are out of time right now. It's 8 p.m. and I think we're done for the session for today. For this particular session, we don't have any assignment. Okay, so this gives you some kind of a breathing room. If you have not done assignments so far, then finish those. You have good number of days. We don't have a class on Monday, I think so. Let me just quickly check my schedule. Most likely we should not have anything.